And what if the entire universe operates like a vast memory system nearing its final limits?
And what if atoms, planets, and galaxies appear only when observation forces them to render?
This is the journey to understand the universe as a finite system of pure information.
What if the reality you experience isn't continuous at all, but processed like digital information? John Wheeler proposed that reality emerges from binary choices, summarized in his famous phrase, "it from bit."
In this view, bits are not electronics, but the smallest answers nature can meaningfully provide.
And if information defines reality, then the universe must obey strict rules about how it updates.
The Bekenstein bound sets the maximum information that can exist inside any finite region.
This suggests
The more we study this, the more reality resembles an optimized system, avoiding unnecessary computation.
this is not magic, but simply nature choosing the most efficient way to store information. Could strange quantum noise be early signs of a cosmic system struggling to process data?
To understand why such limits exist, we must examine spacetime at its smallest scale.
At the Planck length, space-time loses smoothness and stops behaving like a continuous fabric. And if the system exceeds its limit, could it reboot? Or perhaps wipe everything?
It becomes granular, forming a dynamic network that updates itself moment by moment.
This resembles a cellular automaton, where each tiny cell follows a simple update rule.
If space-time is a computational grid, that something must be running on that grid.
And something must define how fast each tiny cell of the universe can update.
In physics, the speed of light sets the absolute limit that nothing can surpass.
The universe simply cannot process information faster, much like a computer hitting clock limits.
If space-time is digital, then the laws of physics describe how its information changes over time.
Einstein's equations define how the grid curves. Quantum rules define how it fluctuates.
Together, they frame the universe not as a smooth continuum, but as a computational structure.
Entropy is not disorder, but information that the universe can no longer compress away.
And thermodynamics, especially entropy, defines the one-way flow that gives time its direction.
This means time itself may be nothing more than a record of irreversible information.
But even storage has limits, and the universe cannot archive infinite detail forever.
When physicists model space-time finely enough, equations begin to resemble a chalkboard grid. This chalkboard-like picture hints at something deeper. Physics may be describing an updating system.
A system that cannot exceed its limits, no matter how large the universe becomes.
These limits appear across many scales, like the cosmic horizon, where light will never reach us.
This is not emptiness, but a region that can never update our local information.
Some physicists believe this limit hints at something extraordinary about the nature of space-time.
In each case, space-time behaves like a product, not the raw material of the universe.
If this is true, then everything you experience is a reflection of hidden rules. Rules that determine what appears, what updates, and what the universe refused to render.
This raises an unsettling question. Is the world continuous, or rendered only?
Quantum mechanics hints that observation itself changes what is real, or what becomes real.
This idea appears across quantum gravity, holography, emergent spacetime, and information theory.
Particles exist as probabilities until interaction forces a specific outcome into the record. The system then reveals only the information needed for the moment, nothing more at all.
And it avoids computing unnecessary details, conserving resources for what truly matters.
This resource-saving strategy appears everywhere, from biology to computation to fundamental physics. Life optimizes information, computers optimize operations, and physics optimizes the structure of reality.
Even consciousness seems to focus only on relevant information while ignoring the rest.
Your mind rendered only what you need.
Principles that govern what is expressed, what is hidden, and what never becomes real.
This leads to a profound idea. Maybe the universe does not store everything all the time.
Instead, it stores only enough to produce consistent outcomes across all observers.
In physics, this principle appears as decoherence, probabilities collapsing into a consistent shared history.
After collapse, the universe no longer needs unused possibilities. They simply fade away.
This is not erasure, but optimization. Why store what no observer will ever measure?
In this sense, reality may only exist where and when information is required.
Everything else remains unrendered, potential, not actuality, waiting for observation to summon it. Cosmic background anomalies and quantum noise may reflect how the system fills missing information statistically.
Each irregularity might be the universe compensating for absent detail with the simplest valid pattern.
This strategy reduces informational cost, maintaining consistency without computing full underlying detail.
At cosmic scales, this could explain Uniformity may not require calculation, just a default value used to fill unknown regions.
But if the universe uses defaults, then it may also use approximations when necessary.
Approximations that are good enough for physics, but hide deeper, unresolved details.
To detect these limits, scientists search for tiny deviations in the smoothness of space-time.
Some telescopes have already reported hints, light arriving fuzzier than predicted by smooth models. But the evidence remains uncertain. The universe may conceal its structure too efficiently. Yet the clues remain. Boundaries, noise, limits, and efficiency woven through physical law.
A universe that reveals only what it must, hiding everything else in pure potential.
And perhaps a universe nearing its limits, where every new moment carries increasing computational cost.
Taken together, they suggest a universe guided not by chaos, but by computation.
A universe that conserves information, preserves structure, and avoids unnecessary processing.
If reality is digital, then understanding these limits may be the key to understanding everything.
It forces the universe forward, consuming its available capacity to store computational history.